Okay, folks watching this on video, we're working on the last part of this page 3 with the loop-de-loop. So we got started on that before I started the camera. So, again, you can fast forward. I might cut some of this out of the video, but fast forward if you need to cut to the chase after you've tried it.
Do it on your actual video. That would be actually
You can totally do that. People actually post, like, I look at videos like that.
I had a celebration thing. Yeah. You need to grow that.
Why not?
Because then you get retired. I'm not retired from here, and then you're like, you know, they make enough money to retire.
You could. You 100%.
Second source of income. That's what I'm saying. You can do any You're fun experience at home. You're a good builder. So you can do fun experience at home. Stuff. Doing it. And then calculate it after. Good. I would watch that.
I would watch that, yeah.
You don't need a lot. Just add
less YouTube, less Twitch, less whatever.
Just get on my clip. My clip. I never watched it.
You can do like live. Okay, guys.
We would support you. We would like to subscribe. We use tagline for it.
Think of that over spring break.
I don't really want to go. Yeah. I'm with you. It's really more like Georgia makes stuff like that. No, Georgia has over. Yeah. I know Carolina barbecue sauce too. Carolina. Real. It's mad.
Oh, there were.
Yeah. Oh yeah, we had a point with Wendy for right. Spoil it, but I need it spoiled.
Okay. I had drawn some things on for the later part of class, but we'll just work down here. So ignore all that for a moment. All right, so I'll start. We have an F straight down. There. Okay, I did my part. What else do we have here? We have friction which way? Down. Of which variety? Flavor? Kinetic, because it's moving. So this is why I make the diagrams bigger. I don't.
It's fine. It's honestly, we'll get it. Don't even put the arrow.
My general practice is not to draw on the provided diagram. Now, if you take an AP test, if they want you to do this, they'll give you a dot. Well, okay, so this is a good idea. Then, if they give you a dot, that's not like extended. So don't do this. mean, you might know what you're talking about, and it might work out fine, but it looks not so good to a grader. And don't do this. Again, you might be able to solve the problem correctly with that. So you just like put them side by side, far enough apart that they don't blend in with each other. Label one FG and one FF. Best you can do. They may give you a box big enough that you can clearly put them separated. And then, is there anything else? Yeah. Must be a normal force because we're on a surface here. Away from that surface. That's one of those, first time you saw a horizontal normal force, you were like, wait, I thought they were always up. No, they're not always up. And anything else? Easy to think that, oh, I gotta have an up for my downs, I gotta have a right for my left, but no. When things are accelerating, expect that it's not balanced. That's why it's accelerating. Or in this case, I guess, if you weren't sure if it was accelerating, well, you know now it is. In which direction is the acceleration? All of that. I heard two answers, and they were all correct. I heard down and towards the center. So, yeah, something like that. But you would still keep with the two separate equations, and we have names for these accelerations. Remember what we call them? Centripetal for this one, and tangential for the one that's going like along the motion. So you could call it horizontal and vertical as well, I suppose, but we already kind of have names that we like for this. So if we say horizontal, aka centripetal.
Would it be radial too or no?
Oh, yeah. Yeah. Okay, so now we have three. Yeah, centripetal and radial mean the same thing. Centripetal is usually only used if you have a true circle, because it means towards the center. If you're on any old curve, then radial is still used, but centripetal sounds weird because there's no center to just some generic curve. So, but nobody's going to have complaints if you do that. All right, so we write all the forces in that direction. There are one. There is one. And then we end it with MA. Now you could do this, but I'd like for you to use the expression for the centripetal acceleration that's on the green page. I want to say number 9 maybe, 14, something on there. You remember what it is? Oh. Yeah, V squared over R. You have to have an R to do that. It's just usually they're going to tie it in with a velocity or rate. Somebody said angular, and there is an equivalent version. Omega squared times R would work. Sometimes it depends on what else is given in the problem or what you're trying to tie it in with. But that's probably my favorite version, at least the starting point. Okay, and then the vertical, aka tangential. Oh, I kind of skipped a step. I thought it was obvious because there's not much choice to make which way to call positive if you only have one direction for your forces. I don't want you to hear debating like, oh, should I call up positive or down positive? Keep life simple. Whichever way the acceleration is, call that way positive. Now, some people hate calling down positive because it's just such a difference from what you've done for years in math class. But you're less likely to make boo-boos. My expression would be, go ahead and shout it out. Okay, so there's the net force part in either order. They're both in the same direction. There's no subtraction to deal with. And then you said, and I talked over it. And then there is no expression for the tangential part that's probably all that helpful. In a typical problem like this, you might be asked, how much acceleration would it have at this moment? And that's just at this moment, because as soon as you move this a little bit, your forces are going to be different. So, and just be careful that this acceleration and this acceleration are not the same thing. You could call them components of one actual acceleration, but it's really unusual to ask for the actual acceleration. Most people just ask about components. All right, that's everything there. Questions, concerns? Either Mark? What makes it? These forces make it accelerate down. In other words, it's moving up, but the acceleration is down. That means it must be getting slower. Now, if I had just asked you, was this getting faster or slower, everybody would have said, well, obviously, it's on its way up. Things are going to get slower as they go up. Well, here's why. Because there's forces against the motion that cause it to get slower. Okay. I'll leave that for a moment. Now, there's a page 4. You might for some purple paper today. Hand drawing this time. I was kind of not knowing how far we get with anything. I was kind of making it up as I went along. Okay. So here's some things that are a little different about these figures. First of all, there really is no context for what these things are. I haven't shown them like as being part of a actual situation. There's no loops and actual objects and parts on ramps and stuff. These are just sort of generic. They are squares. I know they're not drawn perfectly, but they're intended to be squares. The little c is just the center of the square. That's all that means. It's not a thing or whatever. There are two forces shown on each of them, but since they have a mass m, oh, you know what? Something we need to be careful of. And I should have written it, and I just didn't. Your perspective on this is looking at things horizontally. As opposed to, a lot of times you'll get like a bird's eye perspective of things. Like if there was a square on top of this tile, and I grabbed a snapshot of it, it would look just like this too. But you see the difference? The forces, if this were on the floor, would be which way?
Right at you.
No. Wouldn't think they'd be up at me. You can look down at a tile, and then look at your paper, and say, okay, so FA and FB were like being exerted on a square that's on the floor. But yeah, they're parallel with the floor. They'd be horizontal. Like a tug this way or a push that way or something. That's again, if we were looking from a bird's eye perspective, both of those forces would be horizontal. But I'm intending this to be looked at like your eyeball is horizontal. So the missing force, which must be what? What's the obviously missing force? It's on every problem ever. Yeah, gravity. You can't draw gravity from a bird's eye perspective very easily. It'd be like going away from you. It's hard to draw forces that are into the paper. Right? Because the paper is like two-dimensional. But if we look at it this way, then gravity is just our good old-fashioned downward. And it looks fine. So why don't you go ahead and draw a downward gravity force on each of these. That would be a start. When you find these things in textbooks, like they have high-priced graphic designers that make it look really obvious. You don't have to have people hand waving and telling you what it is. So those forces there, the A and the B, just generic. They don't stand for anything. It's not. I just chose the first two letters of the alphabet. That's why A and B. If I'd have had a third force, I would have called it C. So let's start with what we were just doing. So for each of those, write an equation for the two directions, like we did for the previous one. Tell you what, let me be specific. Write a horizontal and a vertical for each one. Don't assume that any forces are equal to each other, that the magnitudes can be anything at all. Just don't make too many assumptions there. Yeah, could be accelerating both ways or just one way, but we won't be specific, so it won't matter. The beauty of what we've done so far is it hasn't made any difference at all where the actual thing was applied. We draw them as dots and squares, and we draw carts as dots, and so that never mattered. For what we're doing now, it doesn't matter. It's going to in a moment. That's a little tease, but for now.
Scare us.
No, I don't mean to scare anybody.
Every time that happens, I'm like, I'm not going to write anything in my notes. I'm not going to write anything in my notes. Yeah.
It was such a good question. I wish I'd have thought of that before I.
We do have ready for liftoff. What? Seriously? Yes. You guys eat it? It was alive. That's how you know it's constant for it. Remember that? I forget what class it was, but there was a bird that flew into the window that died.
That happened in eighth grade.
Oh, yeah. Did you really? But like, there was like a farm outside the window, and like there was a shape-shifting llama and bunny, and then the horse, like horses and cows were ramming into the window, like that. Oh, so weird. And I just remember, like before I woke up, like a horse moving in the window, and he's like, and I'm like running. That's hilarious. I never have dreams like that.
I never did either. I took melatonin and then I started doing it.
By the way, I added a fifth one, but you don't have to do anything with that fifth one. That'll be for part of our conversation later. As you've done before, when you're finished with those four, just run them by some people nearby, make sure you're all in agreement. Don't get nitpicky, as long as they're equivalent.
That's why you ran this way.
Because like this one would be rotate that way,
Oh.
but everything is the same rotate that way. So they're both like okay, cool. I'm not writing it down. B is vertical, so it's only allowed to be A vertical, and then A is vertical. B is vertical. So C is like the comment was more than the comment was like it's very low. Okay. Okay. Nothing on there. I want to know what it is. Is it just a not? Did I just open the word? No, you did like no. Doesn't it have
This one. So gravity would be down.
It should be like back to 8.
Or it should just be 100%. Oh yeah, yeah. You should have less than straight on. So we got a.
You have like 298 for
Gravity.
yes. Well, I literally like I would I mean, I that's so young. So what do you yeah, I I'm so curious.
Yeah, that's not what we're talking about. So here's a little hint. You should have a couple of identical pairs of equations. Even though, I mean, there are some differences here. Yeah.
Even though it's not in the middle, it'd still be the same as this because I feel like, alright, let's pretend this wasn't there. I feel like then it would rotate like a circle almost. But since that's there, like rotating the other way, if they're at the same thing, then it's strict.
So far, we haven't said anything about rotation. So stick with, just stick with what you know about horizontals and verticals, and don't let the fact that it could be rotating apply to anything about it. Alright, it's really fun. I wasn't sure that anybody would recognize at this point what I was doing. Good job. Well, this was the mother that were looking at that, and they have this, not special, but spatial, like spatially. And you're like, wait a minute, that thing's going to do this. And you, I mean, you've obviously got that. Your question earlier about does it matter where the force is applied? For what we're doing here, it matters not at all. Which is why these are identical. And these are also identical. I'm going to cheat, just take a little shortcut, because, spoiler alert, these first two have identical equations. And these last, well, your two, but actually this one that I drew is really no different force-wise from these. So these will all share a common set of equations. And I'm going to kind of cut to the chase just because I don't think we need all the detail of, hey, let's pick a positive and a negative. Now, I will say on this one, I think the horizontal, it's pretty obvious which way it's going to accelerate. There's only one force. So I'm going to pick leftward as my positive just for convenience. But I don't know what to do with vertical because it depends on whether FG is bigger or smaller than, oh no. On this one only, it's obvious. But I don't know which of these is bigger or smaller, so I'm probably just going to go back to what I'm used to with math and call up positive. It could be when I'm all done, like I get a negative acceleration, which just means, oh, guess you were wrong. That's okay. A lot of times you don't know going into the problem what's going to happen. That's why you're doing the problem. So, so this horizontal, that's our only force. So it is equal to ma. And I'm putting an h subscript on the a because, as we pointed out, there's going to be different accelerations in different directions. And this one, I said up would be positive. So fb minus ft equals ma for vertical. You buy that? Now, I don't mind if your forces are reversed because you chose a different way to be positive. That's not wrong. It's different. And then on these, I guess the only difference is we have to do what with this guy? You have to componentize it. And some would say, and it could be a real problem, like, I'm not so sure, maybe it's accelerating that way and you have to componentize those, but it doesn't matter which one you componentize, just sometimes makes it easier or harder. So, FA, and then what? No, because we have another horizontal force.
The sine of 45 FB.
Yeah, I always write it the other way. FB sine 45, or cosine 45, or something equivalent to that. With 45 degrees, the two components are identical. So you could use sine or cosine. There's not a right or wrong there.
If it wasn't 45,
then you would use cosine. I guess, all right. I guess since I labeled that, just for a little more clarity, I probably would do that. Just a statement, not picking on Wall here, but a statement about form. He said sine 45 times FB. If you have a trig function as part of a bigger expression, put the trig function at the end.
I wrote it like that.
But you said it?
Why would you say it?
I didn't know.
Don't ask this question. Okay. And then in a similar way for the vertical, again, just choosing up as positive, so I'm going to elect that to be the first one. They are the same. So I won't, so this time there's a reason I picked 45, so otherwise I'd have just put theta, and then we would have had to use sine. Cosine here and sine. Okay, did I do that right? I try to talk and run at the same time. That's usually not good.
Yeah.
And my A looks terrible. All right. So that was no different than everything you did earlier today and on Tuesday, right? And I don't ever want you to think anything is different as far as the horizontal and vertical. Okay? Now, don't blurt anything out, although we sort of already did. There are 2 of those out of the 5 that are up there now that will also move with another kind of motion. Just like you can move horizontally whilst also moving vertically, you can even have a third kind of motion while doing either of them. And you never have to worry about, oh, is it doing this? Well, then it can't do that. No. You can move 3 ways at once. You can move X, Y, and Z at the same time, right? Doing this kind of thing. So I just don't want you to think, oh, because it's doing this kind of motion, I just forget about everything I already knew. They're completely independent. So can you, I'll just number these. What did I call this one? Oh, actually, 10, 11. So see if you can pick. This would be a total guess. And again, I didn't draw this one on your paper, what we'll call 14. See if you can guess which 2 of those 5 would also be moving with another kind of a motion. Again, don't blur it, just think. Whilst also moving horizontally. Yeah, I always get I get that every Okay, so if that's the worst thing you do today, it's not a bad day. All right, again, no expectation that this is right at all. I just want to see. How many of you think this will also have another kind of motion? Anybody? Just feel free to give it a vote. How about this one? Okay. This one? This one? This one? Okay. Well, I said there were two. So we're not completely right. All right, I'm going to give something away now. There weren't many votes for that. And it turns out that it is these two that will be moving with another kind of motion. So there's something about these forces on these two that are different in some way than the other three. Hard to describe, maybe. It's a spatial. Here's that word, by the way. You're not spatial just because spatial. Now, stick with me for a second. Can anybody try to put it into words? Or I could put it into words.
At the edge.
Oh! Wait, what's it? This?
The forces.
Yeah, but so is that.
Oh, but with that one, it's like on the top, it's moving rightward. So like that makes it spin. Maybe because it's like when you turn it into the components, there's one that's going up, which is normal, but then one's going to the right, which then makes it spin. If the force goes through directly in the middle of the object, then it's just a normal acceleration.
I'm going to twist that around. Just if the force doesn't go through the middle, then it will. Now you said the word. Spin. We're talking about rotation or spinning motion. Any force that doesn't, if we extend it, like imagine extending it, doesn't go through this, like these don't, but this one does. If any of them end up not going right through the center, it can, well, those all do, it can also spin it. So there is a third Newton's law equation that describes things that are accelerating in their spinning kind of a way. Lots of things accelerate in spin. So that's one of the things that will be upcoming in chapter 12, which I'll be putting together. You'll see Google Classroom blowing up.
I won't see it.
Yes. I wanted to leave you just enough of a carrot if you want to come back. All right, no, I didn't need to spray.
Carrots. I don't know if those encourage me.
Yeah, I went over to it. I already bought it. I would So get a little R&R over, I don't know, you don't have to travel to get R&R, but relax a little bit. We got kind of a long stretch afterwards until you're done. I guess you don't have as long of a stretch as some people, but there's no breaks or anything in there. There's still now some debate on whether those air test days will happen or not. the legislature may just scuttle that, in which case there's no days off. Oh, well, I mean Wednesdays, but they're still technically. I'm not even starting.
That was
with
right.
Wednesday.
That was too
Don't start me with the Wednesday thing. All right, 30 seconds good. All right, adios. Be good.
We'll see.
Yeah, we are going to be on the same schedule. No Wednesdays at noon, an hour early, all of that stuff. Yep. See ya. Hello. This? AP Physics. Yeah. Oh, it's good stuff. So fun. No.
Yeah.
Hey, there was a time when you thought adding two-digit numbers was hard. Remember that?